Hello all, welcome back to my channel EduCitare. Today we will be seeing class 12 chapter 7 physics alternating current. Today's topic is alternating current or AC voltage applied across resistor, inductor and capacitor. I have made three distinctions so that it will be easy to understand and also to make note. First, let's see the AC voltage applied to a resistor. Here we can see the circuit. This is our circuit where it has resistor connected to an AC voltage. AC supply as a voltage, that is V is equal to Vm sin omega t, which we have derived earlier. Here we have to find the current corresponding to the given voltage, that is V is equal to Vm sin omega t. We have to find the current passing through the resistor current by the AC voltage. By Ohm's law, we know that I is equal to V by R. So we know V is equal to Vm sin omega t. I is equal to V by R, Vm sin omega t divided by R. So we just take this part, that is Vm by R, which will give rise to Im. It will give I is equal to Im sin omega t. Im is the peak value of the current. Now let's see the sinusoidal wave diagram or the graph. Here voltage and current both are in the same phase. That is, they are not varying. Voltage and the current are in the same phase. That is, they increase or decrease in the same level. That's why we conclude that angle between voltage and the current in an AC connected across the resistor is 0. It does not vary by any designated angle. We see the graph of that corresponding here, where omega t, we have taken sin omega t. So sin omega t is the angle. Along with time it varies linearly. And we have seen the phasor diagram here. Phasor diagram are of two types here. You can choose any one of these for your exams, where current and the voltage vary together. They do not increase, they increase and decrease together. So I hope you all understood AC applied to a resistor. Now we'll look on to AC applied to an inductor. Here we see an inductor connected to an AC circuit. According to Kirchhoff's voltage law, the entire voltage in a closed system will be equal to 0. So we know the voltage is possessed by the AC source as well as the inductor. From AC source, the voltage is V is equal to Vm sin omega t. From the inductor, VL we have to find out. From Lenz's law, we know that VL is equal to this one. VL is equal to minus L di by dt. So according to Kirchhoff's voltage law, the total voltage in a closed system will be equal to 0. So V is equal to Vm sin omega t, VL is equal to minus L di by dt. Adding these two equations in this, Vm sin omega t plus minus L di by dt, which will be equal to 0. According to the above equation, according to this equation. Bringing the minus L di by dt to the right side, it will become Vm sin omega t is equal to L di by dt. And ordering the equation, Vm sin omega t into dt is equal to L di. Integrating on both the sides. There is a trick to remember this. In resistance, we just substitute into the Ohm's law. In resistance, resistor connected in an AC voltage, AC source, there we use Ohm's law. Here in inductor across the AC voltage, AC applied to an inductor, we use Kirchhoff's voltage law. In this particular derivation, we integrate the given equation. Before we just substituted, here it's about integration. So Vm sin omega t dt is equal to L di. As we know the basic integration formula, that is sin omega t dt. Integration is, as Vm by L is constant, we only take sin omega t dt, this part, and we integrate. Sin omega t is minus cos omega t, integration, and we also have to differentiate the inner function omega t in the denominator. So Vm by L d omega t by dt into minus cos omega t, which will be equal to, we have to integrate on both the sides, so integration of di will be I. I hope you all are getting it. So Vm by L omega, differentiation of d by dt of omega t is L omega into minus cos omega t plus c, which will be equal to I. Here I is equal to Im cos, I have taken omega t minus pi by 2. The reason is minus omega t, minus cos omega t, you can take the minus sign inside. Here we'll take the minus sign inside, it will be cos of minus omega t. Cos of minus theta is cos theta. So cos theta, cos omega t will be positive. That is cos of minus omega t will be cos omega t. It will be positive when cos omega t minus pi by 2. That is in the first quadrant, cos is positive. Not cos, all the trigonometric functions are positive. So cos is positive. That's why we have taken cos of omega t minus pi by 2. I is equal to Im cos of omega t minus pi by 2. This is one trick that you can use to remember this equation. Here we see this sinusoidal wave where voltage and current. Here voltage leads current by pi by 2. In AC voltage across inductor, voltage leads current by pi by 2. We can clearly see here current lags voltage by 90 degree, because at this point it is 90 degree. 0, pi by 2, 0, pi by 2, and here it will be pi. So it is voltage leads current by pi by 2, and this will be the phasor diagram where voltage leads current by pi by 2, current lags voltage by pi by 2 in the below quadrant. Now we'll see to the AC voltage applied to a capacitor. We know the voltage formula, that is V is equal to Q by C. V equal to Q by C, right? In the same way, Vc is the voltage across the capacitor is equal to Q by C. V is the voltage across the AC source, that is V is equal to Vm sin omega t. It is the same for all the three derivations. These three are the most important derivations. So Vc, but here we have to note that this is important, that Vc, voltage across the capacitor, will be equal to voltage across the AC source, that is, or voltage produced by the AC source. Vc will be equal to V, that is Vc is equal to Vm sin omega t. And we know Q is equal to Cv from here. So Q is equal to C. Vc will be Vm sin omega t. And we also know the current, which will be equal to change of charge by time. So dq by dt is equal to d by dt. What is Q? Q is equal to Cvm sin omega t. So now we differentiate. Now we saw in the first AC applied across the resistor, it is just substitution, and AC voltage applied across the inductor, it is integration. Here AC voltage applied across capacitor, it is differentiation. So Cvm d by dt of sin omega t. We know simple differentiation formula, differentiation of sin omega t will be equal to cos omega t, and we have to differentiate the inner function, that is omega t. D by dt of omega t will be obviously omega. C Vm cos omega t into omega, C Vm omega cos omega t. Here we have Vm C omega. How do we end up to I? We need to simplify voltage to get current. So we know Xc is equal to 1 by omega c. These derivations I'll be doing in the next video. So Vm by 1 by omega c. We can take this omega c here to the denominator as 1 by omega c. It will be Vm by 1 by omega c sin omega t plus pi by 2. 1 by omega c, which is nothing but Xc. Vm by Xc. Xc acts as a resistance. So V by Xc, which is the current. As Xc acts as the resistance, Vm by Xc, which will be the current. So I is equal to Im sin omega t. Here I have taken plus pi by 2. As we here current lags voltage by pi by 2, or it lags voltage by 90 degree. So cos omega t is positive when cos omega t, it is positive when sin omega t plus pi by 2. This is also another condition. So we see the sinusoidal graph here, which is t versus voltage or current. Here also it is t versus voltage or current. Here it is t versus again voltage or and current. It represents both. So here voltage is in the same phase, but current leads voltage by, see here, pi by 2. This is pi by 2. This is 0. This is pi by 2. This is pi. Sorry, here it is actually 3 pi by 2. Okay. At 90 degree, it varies. So the graph here, the phasor diagram shows here that current leads voltage by pi by 2. These are the three important derivations of AC applied to a resistor, AC applied to an inductor, and AC applied to a capacitor. These are the very, very important derivations of alternating current chapter 7. So please make note of these, and I hope you all understood the derivation and the concept inside it. There's another derivation, AC applied across LCR circuit, that is inductor, capacitance and resistance all together, that I will be doing in the next video. Don't forget to subscribe my channel for more such educational videos and updates about academics. If you like this video, please do like the video and share among your friends. I'll see you all in the next video. Until then, take care.